Hey everyone, this is lesson 1.3.3. We'll be going over some more angles formed by transversals. So the last lesson we talked about corresponding angles, and we're going to go over a lot more on these notes. And so let's start by just it's a little bit of review and practice of some of the previous lesson. And then it kind of introduces some new stuff as well. So here we have same situation where we have parallel lines cut by a transversal. So it's the same. You'll notice the same diagram pretty much in most of the problems we're going to look at. So this is a little bit different if the lines are not parallel. So these angle relationships that we're talking about today are mainly only when we have parallel lines. All right, so things would be the measurements, so the relationships with the measurements would be a little bit different. All right, so let's use what we know about the angle relationships we already talked about. So we can determine the measurements of other angles. All right, so that's the main reason why we're doing this, is so that we could determine the measurement of missing angles. So what's the measurement of angle A or B if I'm giving one piece of information. So in this example, this first one we're told, well, what if the measurement of angle A is equal to 48 degrees? All right, so we're talking about this angle here. So 48 degrees. Then what is the measurement of angle B? All right, so we're trying to figure out why, or really how, can we determine the measurement of angle B given angle A? Well, if I think about angle A, this angle A, and maybe an angle relationship that we know about from before. So the last I remember, we did talk about vertical, I believe it was vertical angles. So vertical angles would be these angles here. All right, so if I know that this angle A is 48 degrees, and I know vertical angles are congruent, these are the same measurements, then this also must be 48 degrees. All right, so these two are the same. How does that help? Well, let me write this in. So this must be the same as 48 degrees. So if there was another angle relationship that we covered where we talked about corresponding angles. All right, so these are angles that if I slide them along the transversal, right, if I slide it, you should notice that it fits perfectly on top of angle B. So that means angle B and this angle are the same measurement, which then must mean that if A and 48 are the same, and 48 and B are the same, then that must mean that these two are the same. These measurements are the same. So therefore, I would say the measurement of angle B is 48 degrees. All right, and since they are the same measurement, then we could say that these are congruent. These angles are congruent. So that's how their measurements are related. So can we do something similar with these three examples? So you'll notice the exact same diagram, except the A and B are relocated. They're in new spots. And so how does the relationship change? Right, so let's see. I already know, and I'm telling you, on all these examples, A and B are connected in some way. There is some relationship. So how is angle A and B related here? So if I look at, maybe if I draw in the angles, so let me do this. So if I draw in, or I color in these, and let's see if I slide this, I know that this fits here. And so if you notice, this is actually completes this straight line. This is what we call an angle pair. I'm sorry, this is a linear pair or a straight angle. So a linear pair because they together, these two angles form a straight line. All right, so then that means this is the same thing as saying this is B. So then A and B must be what? So there's a name the name that we're looking for when two angles add up to a straight line. This would be supplementary. So supplementary. So these two angles are supplementary, meaning they add up to 180 degrees. Now the second one, this A and B are pretty far apart from each other. So they kind of look like on opposite ends. What this reminds me of is kind of reminds me of the first example where we have these angles across from each other. So if I think about it, if I take this, if I take this and I slide it down, you'll notice, let me highlight all of it. You'll notice that they are vertical angles. All right, so the relationship, the angle pair relationship, if I slide it down, is vertical angles, but when it's up here, we can't call them vertical angles because they're not across from each other. So those have another name, which we're going to get to, but how are the measurements related? Well, if these are the same and those are the same, and whenever they're all the same, measurements are the same, we call them congruent. All right, and then the last one, let's look at angle A and B again. So I'm going to highlight these. And so the nice part here is I could actually slide these. So if I take angle B and I slide it on the transversal, anytime you slide it, you're going to slide it on the transversal, not the parallel lines. So you're not going to slide it on those. So if I slide it here, then you should notice this gives us, again, this full 180 degrees, right? Because a full circle is 360, so half of the circle, gives us 180. So anytime we have that, that must mean if they add up to 180, just like we saw over here, they add up to 180. These are going to be supplementary. Okay, so these are the angle measurement relationships that we talked about last time. This did come up. All right, so I know this. Hopefully that makes a little bit of sense. Moving forward, this is kind of giving you some of the same information as last time, a little bit more organized. So the angle relationships we covered last time was the straight angle, which is the linear pair. And so there's the titles. So there's an angle pair relationship. That means how are the angles related? There's a name for it's really based on their location. So if you think about where they're located, then that means they're going to be they're going to have a specific name based on their location. And then how their measurements are related gives them another name. So on the previous example, we were using the angle measure relationship, but there's also an angle pair relationship. So there's a name that describes where they're located, and there's a name that describes how their measurements are related. Are the measurements the same? Do they add up to 90? Do they add up to 180 degrees? So, and I'm going to give you a list of all the angle relationships in this format. So here's an example. So these are supplementary. Again, we don't necessarily need the parallel lines in this example, but this also works. It works if you don't have parallel lines, and it works if you do. So you'll notice all this doesn't really matter, but so it's okay if it's there. It doesn't affect the name. So I've written conditional statements for you that you should know. So conditional statement has an if and a then. So if angles are supplementary, meaning they add up to 180 degrees, then they sum up to 180 degrees. Right? So that's kind of like a simple, it's kind of like a definition, if you want to think of it that way. So here we have the second one's a corresponding angles. We went over that one last time in the last notes, I think in that last lesson. And then the angle measure relationship is congruent. So corresponding angles are congruent. So if the lines are parallel, and this is kind of key, if the lines are parallel, so if the lines are not parallel, that may change the end of this statement. So you need to be careful. These statements are true. This is a true statement only because we have parallel lines. So if the lines are parallel, then corresponding angles are congruent. So you'll notice corresponding angles are congruent. Linear pairs or straight angles are supplementary. All right, so that's what this looks like. So if you're copying, I'm going through this kind of a little bit slower, assuming you probably may be copying this down. The rest of this is going to feel kind of long because it's a lot of the same stuff. But I'm going to try to explain it as fast as I can in a meaningful way, but it still might take some time. So you're probably going to need to review this maybe one other time at least. So here's the new angle relationships. So the first one is called same side interior angles, and the second one same side exterior. You'll notice the name is identical except for one is interior and the other one is exterior. Everything else is the same. So they are supplementary. They are supplementary. So these two angle relationships pretty much are the same, except one refers to interior and the other one refers to exterior. So that's why I've grouped these together. Now, in regards to the picture, in this diagram, what I'm going to do is try to describe to you why it's called same side interior. And so if you ever think of the definition of what interior means or exterior, what do you think of? Like, do you have a clear definition or not? When I think of interior and exterior, one of the first things that pops into my mind is a car. Do you know what the interior of a car is or the exterior of a car? So if you think about a car, I'm going to try to draw a car here, some version of a car. So let's say this is some like an SUV or something. So if I ask you where's the interior of a car, most people know this, like, okay, that's inside. So interior is inside the car. If I ask you where's the exterior, it's like, well, that's outside. So anything below the car or above the car, we are going to call exterior. So if I'm asking where's the interior, we're always looking at these parallel lines like they're the top and bottom of the car. So then interior would be anything in this space. So these angles, you'll notice, are in the interior. They're inside. Right? It doesn't matter their measurements or where they're located. For sure, they are inside. Now, if I look at the example below, if I look at those parallel lines, you'll notice the angles are not in the interior. So if they're not in the interior, they must be in the exterior. So that's why these are called, have interior and exterior in the name. Now the same side refers to the transversal. So if I look at the transversal, are these angles on the same side of the transversal? Are they both on the left side or are they both on the right side? Well, it looks like they're both on this side, right? So we have our angles on the same side, right? It doesn't matter where on that side, but they are on the same side. So these are same side, interior, right? And so now on that one, I'm looking at the parallel lines. So same side, interior, could be over here, or maybe I could have drawn them over here as well. Here at the bottom one, these are also same side, except they're on the exterior, right? This is exterior. We have those parallel lines, but they're on the same side of the transversal. All right. So if you understand that, then the next two that I'm going to show you should seem a little bit easier. So the next two, I've paired these up because they're almost identical to the previous two. They both have an interior and exterior, same idea, except instead of same side, these are called alternate. Alternate interior, alternate exterior. Now, instead of these angles being supplementary, like the previous ones, supplementary, I didn't really talk about that, but the previous ones were supplementary. They add up to 180 degrees. So like if I slide these, they form half of a circle, you could say. Same thing with the bottom ones. If I move it down, that's going to give me half of a circle. So that's 180 degrees. That's supplementary. So on the alternate interior angles, they are not supplementary. It says they're congruent. Well, if I slide it up, they're not in the same spot, but they're across from each other, which means they're vertical angles. And we've talked about this before. Vertical angles are the same measurement. They are congruent. So we saw this in the first problem of the lesson. So if that means these two angles, are also congruent. And so you'll notice it's called alternate. So when I look at the transversal, these angles are not on the same side anymore. So when they're not on the same side, we call these These are alternate. So they alternate between one side to the other. They flip from one side to the other. So alternate interior. If it was down here, if these two are down here, these would not be alternate because they're touching, right? So these would be supplementary angles or straight angle. So they have to be not touching. So here they might share a line, but these angles are considered alternate. So on the same for the bottom example, you'll notice they're kind of on opposite ends of the diagram. And so if I slide these down, those will look like vertical angles, which are congruent. So that means those two must also be congruent. All right. So take your time to copy those down. It's really good, important notes. This is really key information that you're going to need moving forward. So we're going to be using that. So sorry, this is already a little bit longer than I wanted, but I want to throw in a challenge problem. I'm not going to go over the whole problem, but I'm going to leave this here for you to try to finish. This is an example of us using all the angle relationships that I kind of went over. So here's a diagram that has a handful of lines, but keep in mind we only have one pair of parallel lines. Right? These are parallel. So you're looking for, we just happen to have a transversal here, and we happen to have another transversal here. So there's kind of like, it's almost like two different problems on top of each other. So a lot of people get confused. Let's see if you can handle this. I've started this for you. And so I wanted to kind of just show you what I had in mind. And so the first one, I'm going to start with the measurement I know, 57, and I've highlighted a vertical angle. And so I'm like, okay, vertical angles, that's something I always remember, that they're always the same measurement. If you're not sure, just kind of look at it. They look the same size. So it's a pretty good guess that they're going to be. So then I put K equals to 57, or you could write it inside. I would probably write it inside as well. So I'd probably put 57 degrees in here. Oops, looks a little sloppy. And so, and not only do I want to know the measurement, but it might help for you to write down why. And so my reasoning was vertical angles are congruent. Right? So vertical angles are congruent. And so, and then I thought I'd do one more. I said R is equal to 57. That's this one down here. And if you notice, I use one of the new angle relationships. Alternate interior angles are congruent. So if I'm looking at the parallel lines and this transversal, this K and R are on alternate sides, and they're in the interior. They're in the interior. Right? So that means they're alternate interior angles. And then from my notes, I remember that I wrote down they are congruent. So then you'll notice there's no calculations needed. The nice part is you don't really have to do any calculations. You're just saying, oh, I figured out that they're equal, so I'm just going to copy the same measurement. So you're going to do that for a lot of these actually. So try to, if you can, try to finish that. If you need me to give you the answers during class time or another time, let me know if you just want to check your answers on that. Alrighty, I think that's it for now.